Welcome to our channel Circuits Analytica. In this tutorial, we will discuss nodal analysis using the concept of supernodes. For the following network, find current VA and power dissipated by 2.5 ohms resistance. So let us mark the nodes as node P, Q, S and R, where R is the reference node. Mark currents associated with various nodes as I1, I2, I3, I4, I5 and I6. So first of all, let us discuss what is a supernode. In a network, if an independent or dependent voltage source is connected between two nodes, say X and Y, where neither X nor Y is the reference node of the network, then we can apply the concept of supernode. In this network, a dependent voltage source of value 0.8 VA is connected between node P and node S, where neither node P nor node S is a reference node. So we can apply the concept of supernode. First of all, let us consider node Q. There are three currents associated with node Q. These three currents are I2, I5 and I4. Apply KCL at node Q. According to KCL, total incoming current is equal to total outgoing currents. The incoming currents are I2 and I5, and I4 is the lone outgoing current. Therefore, we can write I2 plus I5 is equal to I4, where I2 is equal to Vp minus Vq divided by 2, I5 is equal to 8 ampere and I4 is equal to Vq by 5. So I2 is equal to Vp minus Vq divided by 2, I4 is equal to Vq divided by 5 and I5 is equal to 8 ampere. According to Kirchhoff's current law, I2 plus I5 is equal to I4. Vp minus Vq the whole divided by 2 plus 8 is equal to Vq divided by 5. Rearranging the terms, we can write Vp minus Vq the whole divided by 2 plus 8 minus Vq by 5 is equal to 0. So taking 10 as the LCM, we will get 5 Vp minus 5 Vq plus 80 minus 2 Vq the whole divided by 10 is equal to 0. Rearranging the terms, we will get 5 Vp minus 7 Vq is equal to minus 80, equation number 1. The dependent voltage source of value 0.8 VA is connected between node P and node S. Therefore, we can write Vp minus Vs is equal to 0.8 VA, where VA is the voltage drop across 5 ohm resistance, or we can say VA is the voltage at node Q. Therefore, we can write Vp minus Vs is equal to 0.8 Vq. Rearranging the terms, we can write Vp minus 0.8 Vq minus Vs is equal to 0, equation number 2. Now the concept of supernode. So this is the super node. The portion which is shaded in green color is the super node. Let us identify the incoming currents and outgoing currents for the super node. There is only one incoming current I1 and there are three outgoing currents I2, I5 and I6. I5 is equal to 8 ampere, I1 is equal to 5 ampere, I2 is equal to Vp minus Vq divided by 2 and I6 is equal to Vs divided by 2.5. Applying KCL at super node, I1 is equal to I2 plus I5 plus I6. Vp minus Vq the whole divided by 2 plus Vs the whole divided by 2.5 plus 8 is equal to 5. Vp minus Vq divided by 2 plus Vs by 2.5 is equal to 5 minus 8. Taking 10 as the LCM, 5 Vp minus 5 Vq plus 4 Vs the whole divided by 10 is equal to minus 3. Rearranging the terms, we will get 5 Vp minus 5 Vq plus 4 Vs is equal to minus 30, equation number 3. So now we have three equations, 5 Vp minus 7 Vq plus 0 Vs is equal to minus 80, equation number 1. Vp minus 0.8 Vq minus Vs is equal to 0, equation number 2. 5 Vp minus 5 Vq plus 4 Vs is equal to minus 30, equation number 3. In matrix form, these equations can be written as matrix of 5 minus 7 0 1 minus 0.8 minus 1 5 minus 5 4 into matrix of Vp Vq Vs is equal to matrix of minus 80 0 minus 30. So according to Cramer's rule, we can write Vp is equal to delta 1 by delta, Vq is equal to delta 2 by delta, Vs is equal to delta 3 by delta, where delta is equal to determinant of 5 minus 7 0 1 minus 0.8 minus 1 5 minus 5 4. Delta 1 is equal to determinant of minus 80 minus 7 0 0 minus 0.8 minus 1 minus 30 minus 5 4. Delta 2 is equal to determinant of 5 minus 80 0 1 0 minus 1 5 minus 30 4. And delta 3 is equal to determinant of 5 minus 7 minus 80 1 minus 0.8 0 5 minus 5 minus 30. So we will get delta is equal to 22, delta 2 is equal to 570 and delta 3 is equal to minus 10. Vq is equal to delta 2 by delta, that is equal to 25.909 volt, and Vs is equal to delta 3 by delta, that is equal to minus 454.54 millivolt. So we are asked to find Va. Va is equal to Vq is equal to 25.909 volt. Power dissipated by 2.5 ohm resistance is given as P2.5 is equal to Vs square divided by 2.5. So we will get P2.5 is equal to 82.6 milliwatts. So VA is equal to 25.909 volt and power dissipated by 2.5 ohm resistance is given as 82.6 milliwatts. Thanks for watching Circuits Analytica. Enjoy learning. Please comment, like, share and subscribe our channel.